Okay, so here is the first of a couple of examples I want to work out so that you get a feel for the type of problems that you may encounter in your quizzes and your tests. So let me go to my pen function here. The question says, okay, so it's dealing with a reaction. It says that the concentration of one of the reactants is 1.50 m, and then after 3 minutes, 3.0 minutes, the concentration falls to 0.85 m. And the question is asking for you to use these data to determine the average rate of this reaction in m per second. So basically, the rate of the reaction is going to be equal to, since it's a reactant, minus the change in the concentration of the reactant. I'm just going to call it A for the purpose of convenience, divided by the change in time, all right? Of course, remember the negative sign has to be here because the reactant is being used up. So we put minus, now what's the change? Now the change, as you would have learned before in different topics in general chemistry, change is always regarded as the final value minus the initial value. So in this case, it's going to be minus 0.85 minus 1.50 m, all right, divided by the change in time. And according to this, the change in time is 3.0 minutes, all right? However, please note that the question is asking for the average rate in m per seconds, right? So that means you have to change the minute value or convert it to seconds. We know that there are 60 seconds in 1 minute, and we just do our math from here. In terms of the units, m should be here. The minutes will cancel out, so you're going to end up with m over s as your final unit. So let me do this calculation here. 0.85 minus 1.5, and then we divide that by 3 times 60. Okay, so according to my calculations, this works out to be equal to 3.6, rounded off to 2 sig figs. 3.6 times 10 to the minus 3 m per second. All right, so that's basically how that particular example is worked out. Okay, so let me scroll down to the next example. In this example, it gives you an equation for this reaction here. Let me go back to my pointer function here. So it gives you this equation here, and it tells you that the rate of formation of NO2 is 4.0 times 10 to the minus 3 mole per liter to the minus 1 seconds to the minus 1. So the question is asking for you to calculate the rate of disappearance of N2O5 and calculate the rate of appearance of O2. Okay, so go back to my pen function here. So basically what this question says is that the rate of formation, delta concentration of NO2, which is the rate of formation, is equal to 4.0 times 10 to the minus 3 m seconds to the minus 1, all right? So that's the rate of formation of NO2. Now, based on the stoichiometry of the equation, we can write down a relationship between the rates of the different substances involved in this reaction. So we can write down that minus half of change of N2O5 divided by change in time would be equal to 1 over 4 change in the concentration of NO2 divided by change in time, which is equal to change in concentration of O2 over change in time. Okay, so what are we going to do next? So basically the question is asking for the A part the rate of disappearance of N2O5. So the rate of disappearance of N2O5 is given by all this here, right? So therefore, since we know what the rate of formation of NO2 is, which is this, all we have to do is find out, multiply this by a quarter. In other words, multiply this value here by a quarter. So therefore, okay, so minus half, change in concentration of N2O5, N2O5 over change in time. That would be equal to the rate of disappearance, rate of disappearance forgive my poor handwriting here, of N2O5. All right, so that would be equal to 1 over 4 times 4.0 times 10 to the minus 3 m s to the minus 1. So that works out to be equal to 1.0 times 10 to the minus 3 m s minus 1. All right, so that answers the A part. Now the B part is asking for the rate of appearance of O2. And again, all we have to do is go back to this expression right here. And this time look at the relationship between the rate of formation of O2. Actually, I made a big error. The rate of, going back to the A part, the rate of formation of disappearance of N2O5 is actually given by this part right here. All right? So this is what I need to find. So therefore, going from here, the change in concentration of N2O5 over change in time would be equal to minus 2.0 times 10 to the minus 3 ms to the minus 1. Okay, so this is actually the final answer for the A part, because the question is asking specifically for the rate of disappearance of N2O5. And in fact, the rate of disappearance would be equal to 2.0 times 10 to the minus 3 ms to the minus 1. All right, so please make a note of that. I'm basically showing you, hold on, I'm having a hard time finding. Okay, this is basically showing you the change in concentration, or the rate of change of concentration of N2O5. But the question is asking for the rate of disappearance, which is equal to the actual absolute value, which is 2.0 times 10 to the minus 3. Okay, now, as far as this part is concerned, right, basically, we want to find this, right? So let me just erase some things here so as to make things more clear. Let me erase this here. Okay, so basically, this question is asking for the rate of appearance of oxygen. So delta concentration of O2 over change in time would be equal to a quarter times the rate of formation of NO2, which is 4.0 times 10 to the minus 3 ms to the minus 1. And that works out to be equal to 1.0 times 10 to the minus 3 ms to the minus s to the minus 1. So this would be the answer for the B part. This would be the answer for the A part. All right? Okay, so those are just two examples I thought I should share with you, so that you have an understanding as to what type of calculations you could encounter in your future tests or quizzes. All right, so I'm going to stop here and then move on to the next topic, which deals with rate laws.